Hey everybody, Lars here. Sunday night, although you're not going to get this till Monday. Olympics going on in the background. But tonight's a really quick hit. And tonight's pretty simple. Because what we're going to do is we're going to go revisit Euler 6. And if you remember, we did Euler 6 at the end of Unit 2. When we had iteration, and we had lists, and we had some tools in our tool belt. But now, we've got functions, and we've got libraries, and we've got ways to write it in a better fashion. So I think we're going to do that. And then afterwards is a little extra. I'm going to show you a quick way to create lists inside of brackets. And using this technique, we're going to be able to do Euler 6 in one line. Okay? So sometimes I do it, sometimes I don't. It's a topic called list comprehensions. When we get there, we get there. I don't want it. I want it to be something fun and something interesting for you to see. I don't want it to be something you think you have to master right away and you have to do in your programs. I don't want it to get in the way of you properly learning iteration and doing things well. Anyway, I'll give you another warning when we start out on it, but for the first part of this particular video, I'm going to go back and I'm going to grab our Euler 6 code. And what happens when we run it is we get the answer that we got when we last saw this program, which is the numbers from 1 to 100. I set my limit to 100. And from 1 to 100, I grab their squares and I add them up, and that's the sum of the squares. Then I come down here and I find the square of the sum. We sum them up, and then we square it all, one big number at the end. And then we take the square, the sum of the square, and minus the square of the sum, and we get the answer, which in this case was 251, 64, 150. I'm not going to go back and do it with... Go back to Euler and do it. We'll switch it up and we'll make it 10 again. And if you remember, those are the numbers that we get in the worked example. They're up here in our comments. So we know our code is in the right place. But knowing what we know now about functions, wouldn't it be easy to rewrite a few of these things as functions? Okay? I'm going to rename this. I'm going to call it File, Save As. I'm going to say... Where's Python Data Science? Python Data Science. I'm going to go to Spring 2018, Unit 3, and I have Euler Redo right there. And I'm going to call it Euler 6 Redo Redux, whatever. Okay? And let's see if we can figure out a better way to do it. So I am going to get rid of limit like that. I'll also get rid of that print. And I'm going to rewrite this particular sum of the squares as a function. And how I'm going to do that, I'm going to say def, and I'm going to say, I'll call it SOS, and I will take a limit n, okay? And then, I don't need that anymore because it's going to be defined for I in range 1, 2, and now it's not limit anymore, it's n. SOS equals SOS, or is assigned SOS plus blah, blah, blah. And then I want to return SOS. Yeah? You know what? I don't want to mess. Sum of squares. That's what I'm doing here, right? Yeah, sum of squares, sum of squares, sum of squares. I'll return that. Okay? Because I don't want to give it the same name as the function, because functions typically are variables. Get rid of that print statement, and now we're going to do the same thing, but we're going to do it for square of the sum. So we'll call it square of sum, or do I want to save that for the variable name? Okay, we'll call it square of sum. Good enough. And we also will have n here for our limit. And then we'll write that. We no longer need this because we define it. We can now have that. I'm going to say the sum. Well, I want to do this. Hold on. Did I do it here? Make sure it's indented properly. And then this needs to be outside. And then what we do is we return, return SOSQ, sum of square. Right now, it's the same thing we're doing up there. What we want to do here is return square of sum. And this should be square of sum. I know I sound like a crazy person. All right. So, now when we want to find the answer is square of sum 10 minus SOS 10. So when I do sum of square 10, it'll come up here, and it'll run me through with 1 through 11, get my answer, then square it, put it in SQLS, and return it. Okay, so that should work. Actually, no, I got to give it the name of the... There we go. And I kept that one SOS, so I'll call that SOS, blah, blah, blah. And then I think this is going to work. Let's find out. Uh-oh, doom, 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 doom. Let's see, name limit is not defined. In the second one, I did not put N. Okay, anything else? Anything else you're complaining about? Let's see, no, it dug down. It was just that it didn't like. Or not. Refer the sum is equal to the sum. Oh. Fine. Oh, I don't want to do that. But I do want to say the sum is 0. It is complaining because I refer to it here on the right side, and it doesn't exist yet. So it's saying, huh? What do you mean, huh? Because I got to run a counter here. Okay? This should be doing the same thing, and it isn't because it hasn't been called yet. So we're going to go correct it right now. All right. Hey, 2640. We know that's the answer. Okay? So now if I come down here and I put it in my lines right here, and I rerun it, woohoo, I get 251,64150, which is the answer. So now we have rewritten Euler 6, but we've done it with functions. I've broken out my 2 mini problems that I had to solve, and I created functions that solve them. Okay? So to me, that's a more Pythonic way of doing things. And then when I need the difference, I just do it real quick in a main line of code over here. All right? Now, what's one more thing we can do? One more thing we can do is this. New file. And I'm going to save this as, now, little hint. I opened from my program, which is going to put me in the directory I want to be in. If you do it from the interactive window, it's going to stick you in the home directory of your Python installation. So once you get a program up and you know you're going to be working in a particular directory, use the file new in the program name. Little hint from Heloise there. I'm going to call this my Euler Lib .py. And what I'm going to do, because I'm clever, I'm still going to do comments, because people are still going to come in and read it. Very simple. I'm just going to say Euler Lib. Euler Lib. See, I can still say Euler, even after all these years. And I'm going to grab this and this. I'm going to copy, and I'm going to paste. And I'm going to put them right there. And I'm going to save it. And now, and this is always a scary moment, and I'm going to just delete it all. Okay? So now, all I'm going to do is import Euler Lib. Okay? And down here, Euler Lib.square sum. Euler, I still say Euler. Euler Lib. .sos. Is that correct? Look at that. Okay. Now I change this to 10. I change this to 10. I run it. Got the old answers back, right? Because I am a crazy person and a nut, I am still going to do limit because I only need to change it in one place, not two. That makes me crazy because I'm a programmer. And that still works. And now I only have to change it in one place. And I get my old answer. Look. 1, 2, 3, 4 lines of code. because I'm using a library. I wrote it once, I put it off, and now I can forget about it. I don't have to ever write it again. Got that sum of square problem licked for the rest of my days. Okay? So this code is compartmentalized out in its own library. I use it here by importing it. I created Euler Lib, and it's in my directory, so that's where it gets read from. Then I redo the limit, and if I did it in here, I could make it 3 lines. And I say the answer is the answer, and I run it. And there we go. All right? So to my mind, this is a more Pythonic solution. I've taken my different problems and I put them in functions, and now I put them all in a library so things are compartmentalized. And all I have to do is go there and find the difference right in the middle. You could even, if you wanted to get nuts about it, write a function called difference and send them both to it and then minus them and send it back. But that's a little kooky if you ask me. So I figure I just do it right there in the line. Okay? So we've taken Euler 6 now, what we used to do with iteration and saving variable names, and now we've done it with functions. Not only have we done it with functions, but we've taken our functions and we put them in a third-party library and saved them so we could use them later. Okay? All right. Now, I am not here. But you take a picture, because I'm not putting this up on the web. You can copy this and play with this from the video if you want, but I'm not going to put up Euler solutions, I don't think. I don't know. Did I do the last one? I may have done the last one. Still, while they're going a little kooky and charging money and blah, 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 I do like the idea of Learn Python the Hard Way, where people make you, where you have to type in the code. You don't just cut and paste, you type it in. Because if you type it in, you make mistakes. And if you make mistakes, you have to correct them. And in order to correct mistakes in computer programming, it means you have to understand what's going on. And if you make a mistake and then you have to correct it, and that means you have to understand what's going on in order to correct it, that's called learning. Because that's how we learn. We make mistakes. We're screw-ups. We're mimics. But when we mimic things, we make mistakes. And then we discover why, and we understand systems, and then we correct things that way. It's fault tolerance at the end of the day, said the geeky programmer. All right, as usual, I digress. Get a good look at this because I'm getting rid of it. And we are, actually, I'm going to do this. I'm going to run it one last time, and that's going to give me a nice, clean, interactive window so you and I can play. I promised you a way to do this problem in one line. We are going to talk about list comprehensions. Back in the old dinosaur days, there used to be conventions for mathematicians to write down certain sequences or certain lists of numbers. Like they could say x for x in 1 ... space 100 if x is even. Okay? That's kind of a mathematician way for you to say, give me a list of 2, 4, 6, 8, 10, 12, blah, blah, up and down the line. Python provides a way to do that a little using programming syntax. They're called list comprehensions. And a real quick example of one would be something like this. Open bracket. You're always doing this within a list, so do it within a list. And I will say x for x in range 1, 11. Okay? So that means give me an x for every x in range 1 through 10, because 11 is the first thing I don't want. This should produce a list for me that contains the numbers 1 through 10. And as you can see, that's what Python returns. I can make that equal to a variable. So if I want to, I can say a and take my list comprehension and do that right there, print A, and I get my list. My list is now 1 to 10. So I created that list by kind of doing the formula inside the brackets. That's called a comprehension. Okay? Now, if I want, I can even do something like this with if statements. If x modulo 2 is equal to 0, that means it's even, then, hey, first time, I get the evens. You see? So basically just think of a list comprehension as the range and the rules of my list inside the brackets, and then Python works it out and gives you those results. Okay? So let's think about what we just did, all right? We did the sum of the squares. We did the square of the sum, which was the big one. We'll do that first. So how would I do something like a square of a sum? Okay? I would probably start a parentheses because I'm going to want everything grouped at the end so I can square it. And I'm going to say, give me the sum of x for x in range 1, comma, we'll do 10 at first. Okay? That does that, and that does that. And then what I want to do is I want to square this, right? Hold on a minute. I want to make sure my brackets are... Sum of that, no. I want the 3. And then I want to square that. And then I want to close the bracket. So that should give me, what's the big one? 3,080 something? Hold on. 3,025 is what it was. So that actually works. Okay? So I know I can do that part. That's pretty easy. Let's try the second part. What is that? That's even easier. That is the sum. I don't need to bracket this way. I'll show you why in a second. Of x squared for x in range 1, comma 11. Close that one. Close that one. Close the list. Are the gods with me? They are 385. Okay? All right, so you can see what it produces as an answer is a one-item list. But basically, I'm coming up with these answers by creating a list comprehension that gives me my range and does some functions and gives me the number I want. So, at the end of the day, if I wanted to do this all in one line, right, I could grab, let me start a list, because it is a list comprehension. And I'm going to grab the big boy first. Copy. And I am gonna put it in parens. Control that. And I'm gonna minus, open paren, this. Alright. End the brackets. Oh, it's telling me I'm wrong because I have the new paren. And so I want to do that. And then I'm going to end my brackets and grab the whole thing. Ladies and germs, if I am not mistaken, this is going to produce the answer for 10, which was what? 2026 something something? Let's find out. Ha-ha! So in one line, we've done Euler 6. Now, just so we can compare to what we have above, I'm going to copy it. I'm going to paste it in there. But I'm going to come back here, and I'm going to change my ranges to 101. And there we go. We've done Euler 6 in one line. Now, remember, this is just having a little bit of fun. You don't have to think you have to think this way or understand how to do all this, and that you should be doing homework problems in one line. Get that out of your brain right now. I want you to do regular iteration. I want you to iterate over lists and do things inside of code blocks like regular programmers. I'm just showing you a little fun, extra Pythonic kind of thing on the side when I tell you about list comprehensions. It's possible in the brackets of the list to define the thing. So if you want the even numbers up to 100, you don't have to go my list equals open bracket 2, 4, 6, 8, dar. You can do a list comprehension, and it'll create the list you need for you. Okay? And as you can see, if you use this example again, I'm not going to put it up on the... I'm definitely not going to put it up because it's not a program. I'm using the interactive window. Okay? But if you look at some of the different things I did here, you can get a gist for what you can do with comprehensions, okay? You can pick numbers out of ranges. You can manipulate the numbers you pick out of ranges. And you can even manipulate the number you pick out of ranges and then do comparisons to see if they meet certain criteria, okay? So that's list comprehensions. There's a little Easter egg for you. I don't want you to go crazy. If I find a comprehension in a program and it breaks, I'm going to yell at you. So if you do use it, make damn sure you're using it correctly, because I don't want to mess you up. I don't want you to think, oh, I got to use list comprehensions now. I got to understand how to do this, blah, blah, blah. This is something that will come along with the territory as you practice. As if you haven't figured it out yet, computer programming is about practice. Practice, practice, practice. Go to Euler. Do some problems. Do your exercises at the end of the slides. Do all of these different things in the book. Practice, 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 and then slowly but surely you'll get this understanding. It'll pop into your brain. Ah, I know this syntax well, and I know how to manipulate numbers, and I know how to do things like that. And pretty soon, for simple tasks like Euler 6, you won't be writing programs. You'll be jumping into the interactive window and just banging them out like we did right there. Okay? All right. Then I'm going to get out of here. No announcements. You've already gotten a ton of announcements from me. We're going to meet for class soon in about a week. You better start thinking about making groups because your final project is going to be a group project. Keep chugging away with Unit 3. Grades are on the way. How's that? Quick announcements, all right? Then I'm going to get out of here. I'm going to go watch the Olympics. It's on for another couple hours. And then tomorrow's Monday, which is packed. And then the next day is Tuesday, which is packed. And then Wednesday, I got to go to Baltimore. So there's no rest for the wicked. All right, I'm getting out of here. I will see you. This is the last video for this unit. So I won't be doing a bunch of videos for a while, but you know me with announcements. So you'll be hearing from me very soon. All right? All right, then you be good, and I'm out of here. Bye.